Welcome to Flat Earth United. I'm your host, Nathan Oakley, and tonight I'm joined by Sleeping Warrior for an update on the Isle of Man and Ireland. We're also joined by a special guest who I'm sure Sleeping Warrior will introduce in just a moment. So over to you, Sleeping Warrior. Good to have you here.
Hi, Nathan. Okay, so obviously there's been a bit of debate in the last 3 or 4 days over what can we see, what can't we see. I'll just start off with my assertions, my position. As far as I can see, based on the evidence, we're seeing Ireland. If we're not seeing Ireland, we're seeing the extremities of Isle of Man. Either way, they're supposed to be behind the curve, the alleged curvature of the Earth. Ranty's had a go at doing stuff. GeoStreamer's had a go at doing stuff. Jeremy's had a go at doing stuff. Pompous has had a go at doing stuff. Everyone's had a bit of this. And really, we're all arguing with each other and not really proving stuff. So nobody trusts anybody. Everybody's blaming everybody for everything. So I asked if anybody knew anybody that could help model this in a way that was more convincing, persuasive, or accurate than what we're all able to cumulatively get. And Chris said I might be able to help you. Show me what you got. And I just said, this is what I've got. I've got this video. Ranty's got this long, like portrait photo. Take that, see what you can come up with. Are we looking at Ireland at any point? If so, where? And can you confirm other aspects of what we can see? And basically plot it all together in such a way to make it pretty. Can you work out, are we seeing Ireland at any point? And if so, where? And how much? So he said, leave it with me. A couple of days later, this is the proceeds of where we're at now. So if I'll just pass you to Chris and he can talk through what he's done, how he's done it, and then show the results and tell us what the conclusions are. The answer to the question is, are we seeing Ireland or not, Chris? Yes or no? So Chris, tell us what you did, how you did it, and what is the conclusion?
All right, I'll try to go through it as quickly and concisely as possible here. What I did is I went to the area in question and grabbed a screenshot from just a straight down shot on Google Earth of the map. And I put a 2-scale 50-mile grid over top of that. So it's this square, the grid square is 50 miles by 50 miles to scale. And I put essentially a camera right at the point on the map in St. Bees where Anthony took his footage, and also where Ranty composited the pictures from in his pictures and so forth. And the camera is set to 2000 millimeter zoom, which is about the maximum extent of Anthony's camera. And then I put that into a 3D model here. And so that I was unbiased in the data, in the actual model, I went and did the same thing. I went directly to the video, grabbed my own bunch of screenshots, second by second, and then lined them up to create the horizon line. So if I zoom in on the map down at the bottom here, you can see it's a 3D model with the pictures laid out in a composite. The horizon was all mapped out, and I matched it up with the clouds and land masses on the map. Set that to the point of what everybody kind of agrees on is the lighthouse on this peninsula here. There's a lighthouse out here on the map. And so I lined that up on the map. And I'll show you when I take the camera here. So the camera view, up top here is the camera. The orange outlines the camera. Roughly where this cursor is the center of the shot in this particular shot. Now what I'll do is I'll take that camera and rotate it on the Z-axis. I'll just go back to 0 degrees. Right, so when the camera is lined up on that line of sight that we had previously established, and everybody kind of agreed that was from where Anthony was standing over to the Isle of Man is that lighthouse, and that's it right there. And if I zoom in on it, even further, you can see that it's clearly the lighthouse, because there's basically the lighthouse starts here. It's a white front on it, and it has a black top on it, And up on the hill is Buddy's house that owns the house and properties up in that little area here. So clearly that's the lighthouse. And that's measured at 39 point, how many miles is that? 32.51 miles, right?
I'll check it for you. I'll check it now. Hang on.
Yeah, 31.52 miles. Okay.
I'm just getting there. Hang on.
All right. Well, while you're looking that up, I'll swing the camera. I'll take our camera here and move it back. Let's go this way to the far end. Now we're zooming up to the end of the Isle of Man here.
Yes, 31.52 is bang on.
31.52. Okay. Now, Anthony had asked me, we were trying to figure out in the footage what this thing is here. I'm going to zoom up a little bit. So you see that thing right there on the water? I'll put my cursor below it so you can actually identify it. And when I zoom into it, you can see it has a bit of a ridge to it and a white thing on the top. If you could zoom in closer, I bet you would see that there's a rail around that where the actual light is in the second lighthouse, which is actually at the end of the Isle of Man.
It's called Winky.
Winky Lighthouse? Winky Lighthouse?
Winky Lighthouse, yeah.
Yeah, yeah. Okay. So when I swing the camera through the image on the same 90-degree parallel line, the camera ends up right there at the tip of the Isle of Man. And that's the lighthouse that you see. See, when I set it to the picture, if I put my cursor in the picture, it lines up to that image on the 90-degree line. So
that's in contrast to what I thought I was looking at a buoy. Now, when I've lined up the two buoys that are in the North Sea, and I was working on the assumption that we're looking at one of the buoys, and Chris said, "No, you're actually looking at the lighthouse on the end of Isle of Man."
Right, that's the lighthouse. This lighthouse, I think, was 110 feet tall, or roughly 37 feet plus 17 feet. Or so we worked out the height of it. There's about 10 feet of it sticking out above the top of the mirage, actually, because there's a wave. Basically, there'd be a wave in front between you and the camera. There's a wave. Probably the tide's coming in or going out, but there's a wave, and the rest is just heat and mirage. Now, I confirmed that by the trigonometry. We took the distance from the observer here to that lighthouse, measured it to be 31.34 miles. And when I did the trig on that, it works out to exactly 15.48 degree angle. So the angle between the observer, this lighthouse on the island that's 90 degrees across, 90 degrees to this one, is about 15.48 degrees on the theta right here. Okay.
Now the distance in miles from the observer is 31.09, and then when you put the viewer height, whether you put in 35 or 50 or 100, I mean, I'm going with 35 because that's what your model tells us it is, 35 feet. That comes back at 309 feet. But if you put it in at 50 feet, it still comes back at 270 feet. And the lighthouse is only 100 feet tall. So that whole lighthouse should be gone behind the curvature of the Earth. Oh,
there should be at least 120, 130 feet or more. You could do the math on it. But yeah, well over twice the height of that lighthouse should be completely below the curve on the curve model. Yeah. You shouldn't see it at all. Yeah.
But then that leaves the landmass behind it. Now, that's on a bearing of 261 degrees. And the land behind it is 79 miles away. 79.39 miles. If you go with the 35 feet, gives us a refractive hidden of 2,927 feet. If you go with 50 feet, that gives us 2,803. But if you go with 100 feet, which is what Lewis wants, it's still 2,500 feet. Guess what the elevation of that land is in the background? The elevation of the land in the background is... Getting it on my screen.
I think it's like, yeah, but this is going to be a little contentious because what you're not actually seeing the land of Isle of Man. You're seeing land elsewhere.
Yeah, it's probably higher land in the background, but in any event, it's still 79 miles. It's supposed to be behind at least 2,500 feet of curvature. Now, this is where it comes down to the ball as to work out I mean, how accurate is this information, Chris?
It's to within a half a degree.
Yeah. So within half of 1 degree, when over a big distance, half a degree is quite accurate.
Yep.
Well,
I mean, yeah, because I got the camera set to be a 2000 millimeter zoom, right? So you can see if I click like a quarter of a degree, it swings a long ways, right? So it's within a half a degree accuracy to the center point of the camera.
So, in your opinion, based on the model that you've built, that you've constructed at my request, not using anybody's data other than the raw information that we've got and that we've given to everybody, do you agree or disagree that the land in the background is Ireland?
Behind that lighthouse, yeah, that'd be the town of I can't remember the name of the town now.
Portaferry,
and or be in that
Bailey Hornan.
Ardglass, Portaferry would be the line of sight, probably in the town of Ardglass and Portaferry. Yeah.
So again, just for clear sake, you do agree that is Ireland, yeah?
That's Ireland in the background, yeah. You're looking over top of the lighthouse, and you're seeing Ireland in the background, Portaferry area, or Ardglass. That's a little town way back. Yeah.
Now, even if we give that's 79 miles, guys, and even if we give you a viewer height of 100 feet, that means it's still 2,500 feet behind the curve. That cannot be seen. So how is that possible if we do indeed live on a ball? So that is Ireland. So if you're ready to move down now to the southern side of Isle of Man, Chris, or unless you've got anything else to say about the north.
No, that's definitely Ireland on the top. I agree, and I'll zoom down I'll rotate the camera to the southern side. Let me zoom out a little bit in the top view here so you can see a little bit better picture. Oh, one thing I did want to tell you. Let me see. So that's that there. Let's go down to the bottom side. Rotate. Okay, yeah, I wanted to show you this. Okay, so yeah, because this will kind of mess people up when they're looking at that image. Okay, so this is a picture of the camera. I just swung it to the left. I'll zoom in on the map below to show you approximately what I'm looking at. There's a mountain here where there's a radio tower, 1,200 feet high or whatever it is. But there's a mountain and it comes down along this way. And then it slopes off quite sharply. So the camera here is looking basically down through this valley. And the valley is down in here somewhere behind the wave. And if I swing it to the other direction, camera. This is fun trying to do all this stuff live. Eh? You'll see that there's no land there as I swing across that plane between the mountain drop, which starts up here. It drops down through the valley on the lowlands, and then it picks it up here, which you can probably go to Google Earth and zoom in. You'll see that little cliff there, right here, it's there, right? So I confirmed that exists.
Yeah, that does match up.
It matches up perfect, yeah. And that's a good spot to look too, because you can see that a lot of what you're looking through is actually mirage. Like this would be a mirage line. So it's a bit of an illusion. The lighthouse is actually sticking up through the mirage kind of thing, right? But it's actually happening. Yeah. It's fascinating.
But most people, we're not seeing behind the curve of the Earth. We're just seeing the mirage that's blocking out the land that is the low-lying land in Isle of Man.
Well, yeah.
60 feet.
Yeah, well, mirrors and mirages only work on flat planes anyway. It wouldn't happen over a curved ball. It just physically doesn't happen. But,
yeah, but that's another point for another.
That's a whole other debate. Yeah, a whole other point. Yeah. But
we're thinking about you, Arave, at this point. So anyway, so let's go down the other side.
I'm going to swing down to the other side. Get my camera going.
Swing.
Oh, swing. Swing, camera, swing, yeah. Then I got to angle it back down a little bit here just so you can see the guy in the boat. Okay, then I'll zoom it on the map. So the guy in the boat's offshore of the Isle of Man. Well, he's probably out here somewhere, because he's quite a bit closer, obviously.
Yeah.
But if I swing the camera in until you see land in the center of the frame, roughly there, give or take. You can see that that is the other bottom, whatever that is jutting out there, a little peninsula on the other side of the Isle of Man is right there.
Now, therefore, the question is, are you sure that that's not Ireland? Are you sure that's Isle of Man?
That's Isle of Man, yeah.
Now, the only reason I'm asking that with emphasis is because the elevation of that point there that you're identifying is somewhere between 15 feet, which is the thin bit that connects it to the mainland, down as high as, or as high as, or, well, up as high as 45, 50 feet. That seems to be the highest I can pick off on the peninsula that you're identifying. Now, even if this is the Isle of Man, and I'm happy
well, that'd be about right. I think that'd be about right, because the center line of that mirage would be, by just basic trigonometry, would be the same level of plane that you're standing on taking the photo or the video. So if you're 50 feet in the air, roughly, give or take, then that's what you would see as your focal point in the mirage.
Can you zoom in on the photo, Chris, just so it's clear to the audience exactly what land you're specifically saying is the Isle of Man on the actual photo itself? Can you zoom in?
Right where that, so right where that cursor is, from there to there, like this is whatever is in this starting point right here in the center of the camera, matches up on the map down here.
Just zoom in on the map part.
Yeah.
I would argue that it misses.
Well, I mean, it's within half a degree, right?
Can you prove
this? I had to take the shot from like Google Earth and try to line it all up, right? So I mean, it's within. I can show you it's within half a degree. So the orange lines on the map here, where my 3D cursor is roughly the center of the photograph that you're seeing in the camera frame, which is pointing at this tip of this peninsula. And when I zoom out, it's right there, right?
Oh, right, I see it.
Right. So now, if I move the camera on the Z-axis, just to show you how accurate that is.
By half of 1 degree, yeah?
Right now, it's sitting at the center point where that target is at 11.8 degrees, right? Now, if I move it 1/10,
yeah,
right, 11.8, now we're at 12 degrees, right?
You're going the wrong way, though.
Oh, yeah, so 11.8, if I go the other way, 11.7, 11.6, 11.5, 11.4, right?
So it's within half of 1 degree.
Yeah.
Right, I'm happy to accept that is Isle of Man, but this now creates another problem, because that distance, according to the curve, according to the Google Earth, 79.39 miles. Okay, and the viewer height, if we put the viewer height at 35 feet, I mean, you can check all these figures yourself. I'm not going to screenshot.
This here to that distance, just based on that, would be about 51 miles to that point. Right, 79 miles would be to Ireland and 51 miles to this peninsula. If I did the math on it, I can tell just by looking at it.
I've got it at 71 miles
to that peninsula.
From where let me just make sure I've got this right. This is in miles. Yeah, I've got it. One end is where I'm at St. Bees, and let me get down to there. That peninsula down there. Make sure I'm being thingies here. Oh, sorry. Yeah, I apologise. I've misspoke. It's 50.45 miles. I don't know where I got 79 from. 50.
Right, so I didn't even have to figure that out. I could just tell by looking at it. It was roughly 51 miles.
Right, so I apologise. I misspoke. I was looking at something accidental, but this is where we correct things, and it's fine if you make mistakes. It's fine.
Yeah.
Right, 50 miles away, right, at 35 viewer height in feet. 35. We're going to go with 35, 50, and 100. So, and the 100 is just because of Lewis. In any event, 35 feet. It's supposed to be behind 1,038 feet. 1,038 feet. What's that in miles? Let's go to metric. 316 meters. Imperial is 1,038 feet. And then, so if we go to 50 feet, it drops down to 965 feet. I mean, that's hardly made any difference. Let's double the observer height to 100. Still 791 feet. And we're looking at land that is 50 feet in height. It's. How is this explained?
What was the figure again? 700 and what at the minimum?
Do you want it at 100 feet or what height do you want?
At the minimum, so yeah, give me 100 feet.
So the highest one, this is Lewis's magic maths, 100 feet, it's 791 feet behind the curve. That's the refractive hidden value.
So from an observer height of 100 feet, We've got
Yeah.
971, did you say?
791
Sorry, 791
feet of refracted hidden.
Which means that there is a wall, there should be a 700-foot wall of Earth between us and the thing that we are actually seeing. And there is no wall of Earth between us and that target object.
Now, this is the bit where I don't think half the ballers realise, because this value is much higher than what they've ever been playing with before. If it's that land at 50 feet in height, it should be 850 feet. But the value of the land is actually 50 feet. That's if we can see it at all at that distance. So that height on your maths, your ball earth math, should be 850 feet of elevation for that land. But it's only 50 feet. Where is that curvature? Now, this is where they go into bendy light, refraction, and all that. But this is where, in a concise sentence, it's only refraction if you can see evidence of non-standard refraction. Because ordinarily, normal refraction, standard refraction, is negligible, and that's not worth calculating for. So we're not going to calculate for it. So we should dismiss the calculation adjustment for standard refraction and go back to what it is without ignoring refraction. And that value, based on 50 miles at 100 feet, goes up to 973 feet from 791. Because refraction, the adjustment for refraction is negligible and it's not worth calculating for. So really, unless you can claim that there's a Fata Morgana or a superior mirage or an inferior mirage, and there isn't any evidence to support that, yeah, there is something on the horizon, I grant you that, but you can't quantify to what effect it is. And my position is,
if we ignore the holographic effects that they say are happening because of this imaginary almost 1,000-foot wall that we're not seeing, we can just take it as read that we can just see them, correct?
Yeah, exactly. We can just see them. We're not looking at holograms, not looking at magic maths, bendy light, Mick West, none of that stuff doesn't exist.
We just see
We're looking at this. Yeah. What would be interesting would be the effect on Coriolis if we got a rifle and tried to fire a bullet 50 miles, and how far out would you be by the time it got there because of the apparent rotation of the Earth?
Okay.
Obviously.
This leaves a bit of a problem, though. So if you've identified it'd be the most westerly point, wouldn't it, that we can see?
Yeah, from this perspective, yeah.
From this perspective, what's the rest of it then?
The rest of what?
The land.
It is all of Isle of Man. We're looking at Isle of Man.
Except for the northern, the farthest northern, you're actually looking over top. You're actually seeing Ireland in behind that lighthouse. So Ireland is 80 miles away. So right, then you got to the.
Chris, spin it back around and go back to the north.
I'll have to put that map. I was playing with it while you guys were chatting there a little bit, but hang on a second here.
So if you can get us back up to the north, we can answer his point, and I'll just fill the gap in while you're doing it. So all down that side that's looking on the south towards the south, we're not seeing Ireland. My assertion fails. We're seeing the Isle of Man. However, it's 1,000 feet of missing curvature. 1,000 feet. That's 330 meters. Where's the curve? Okay. However, it's not the same in the north. My assertion was in the south we were seeing Ireland, and when Mark Taylor and Paul said, why aren't we seeing Ireland in the north? I thought that was a valid criticism. So we came back and revisited it. And when we come back and visited it, based on modelling, proper modelling techniques that I can't do, and I admit I can't do it, but you ask somebody that can, Chris can do it. He's now showing that there's two buoys in the middle, or what I thought were buoys, turns out to be the two lighthouses, and they are on the extreme tip of the Isle of Man. That means that all the land that's behind the buoys or behind the lighthouses is Ireland. And Chris has already confirmed it.
Yeah, that hill, there's like a town of, so that the elevation there, or the distance is 80 miles to the back side there, and you got whatever it is to the lighthouse. We measured at 31 miles, so it's 31 miles to this point, 80 some miles to the back point, and that's Ireland, right? So the drop would be whatever you guys just said there. You did the calculations, 700, 800 feet. Yeah.
So that little stumpy thing that looks like a boat, that is 31.09 miles away. So 31.09 miles away. Viewer height put it at 35. We'll put it at 50. It's in the middle. We'll go with the 50. That should be behind 270 feet of curvature, and it's only 100 feet in height. That means we should not be able to see it. Cannot be seen if we live on a ball. Now, I don't think that the ballers understand that. Nath, do you want to paraphrase it into a different language so that they can?
There's no curvature blocking our view of that lighthouse.
Would you agree, Chris? That means that we're seeing across a flat plane. If it's not flat, it's huge.
It's a flat plane. It's a flat plane, and you have 80 feet of like between you and that point. Right, is the highest is 80 feet of difference in the refraction. That's all that is.
So
there's
now
no curve. There's no curve, and you're not standing behind an 8 or 1,000 foot wall.
No, I agree.
Curvature.
It looks exactly the way it sees on the camera. We're looking at it the way it is in real life. There's no mirage here. There is a little bit of horizon distortion. I agree, but there's no. We're not. Unless the ballers can prove that there's evidence of either looming, towering. There's no looming on that picture. There's no towering on that picture. What's the refraction that would be non-standard refraction? And the answer is there is no evidence of non-standard refraction. That the effects are negligible, and we're seeing the negligible effects on the horizon. That's what refraction is.
I've got a way to visually show it. So if I use Ranty's depiction, so it's not going to be on your screen for a minute, it'll be on mine just while I show the audience. So
this is just before you switch. So here's a good way to put it. Maybe it'll make sense to people because it's a flat plane, and you're looking through a camera. This spot here, wherever the reflection of the mirage flips over and becomes like a mirror image of itself, at that point is exactly the same height as your camera, always. So if you're at 50 feet elevation plus the height of your camera, so say 55 feet, then I can pretty much guarantee that elevation there is 55 feet in a straight line, right? So you can calculate what's sticking up through, right? It's interesting. Yeah.
So the question now is, where is the evidence of non-standard refraction? Because the only refraction that we see is negligible. It isn't worth calculating for, and it's standard refraction, as you call it. For everybody else that realizes that we don't live on a ball, it's just refraction. But you guys have got two compartments. One's called non-standard and one's called standard. This is standard refraction we're seeing. It's negligible. It isn't worth calculating for. Where's the evidence of non-standard refraction?
Now, let me just put their claim out. So it's now on, as I say, Ranty's photograph. So just so it's absolutely clear as crystal what we're talking about. The wall of Earth curve is up to this line. Therefore, the fact that we can see everything below this line means that it is a hologrammatic effect that is bringing this back into view over the wall of Earth curve that is this high. And because we are looking, as we go from right to left, we are looking further down the coast, further over the curvature, according to them. Therefore, this line gets more and more significantly worse till we reach the point where we're at the absolute extremity that we can see on the Isle of Man, and we have 300 meters of missing wall not blocking our view. Again, for them to make it work, they have to use favourable non-standard refraction to bring this land up 300 meters in order for it to be visible beyond the wall of Earth curve that clearly is not there.
I'm playing about with the distance in miles at 50, which is the peninsula on the far side, on the far left-hand side. And I'm playing about with the viewer height. So if I put my viewer height up to 200 feet, that then brings it down to 559. So let's try 300 feet. What does that do? 300 feet.
That was awesome, Nathan, because when you were saying that, just as a jovial thing, it was I had this insatiable image of Pink Floyd, The Wall, with their bricks falling down in my head as you were like, the wall. It was like, that was cool. Yeah, it was awesome.
Right, I've got it up to, I'm now at 700 feet of viewer height, and that gets it down to 128 feet. So we need 800, let's try 800 feet. 800 feet drops it down to 90. So 900 feet drops it down to 60. So it's still hidden. It's going to be 1,000, isn't it? Right, 1,000 feet. If the viewer height was 1,000 feet, then the refracted hidden would be 38 feet, and you might just see the tips of the peninsula that we can clearly see everything of. You'd have to be stood 1,000 feet in the air to be able to see it. And I'm only 6 foot tall.
This is why we
and I
were
was a
getting so
roundabout.
frustrated with people like Lewis when he was saying, why can't we see the beach? It's like, you don't understand the enormity of the problem you are facing here, Globers.
Yeah, picking on the sand, the grains of sand on the beach is the least of your problems. You
Moot.
need to be explaining why I'm not at 1,000 feet in height to be able to see what we're seeing. I'm at 50, 100 feet. That's all I'm at. So where's the other 1,000 feet that I'm not at to be able to see what we're seeing? Or, in the alternative, where's the evidence that supports the assertion that it's going to be non-standard refraction? Because the only evidence that we can see is a little bit of a refraction on the horizon, and we all know that the effects of refraction are negligible and not worth calculating for. It, to me, looks like you're all at checkmate. I don't see how you can get past this. You need to come up with some magic mistake that Chris has made, or you need to prove that something's gone wrong in the modelling, or you need to prove something else. But it's totally and utterly ball in your court now, ballers. What have you got? How's anybody going to show that this is still consistent with a curve?
Did you have any last comments, Chris, before I round out and thank the audience for watching?
Just quick. I'm not from your area, so I don't know anything about the Isle of Man. I just did the model as per Anthony's request. I am curious. Just, you guys might know the area. What is that town that's on the horizon there?
Zoom out a little bit. Let me see where you're looking.
It would be. Oh, I guess it'd be Douglas, would it not, or part of Douglas, somewhere in that ballpark? Yeah.
Well, you tell me. You zoom in, because this is, I think, the town that you're looking at. Oh yeah, it's the right. This has been right. We originally identified this town as Douglas, but we were told that we'd made a mistake, and therefore the rest of our claim fell apart, which is ridiculous. But that's what they told us. And the mistake that we were told was that town was actually called. I'm getting it now. Bear with me. Right, there's Douglas. So it's the next one up. It's called Balacanel. Double L, double N, double L. Balacanel. Can you tell me what that land is by zooming in? Because the assertion was...
It looks like you're kind of looking through... let's see here. You'd be catching part of the front face of this coast. If there was a little town, you'd catch part of Douglas in here somewhere. I would assume part of Douglas, and part of, if there's another little town in here in front of Douglas.
No, you've either got Balacanel on the right or Douglas on the left. So if that's... Move the frame over to the right a little bit. Does that then center it on the top?
I'd say that's Douglas, probably. I don't know how big Douglas is, but...
Well, it's the capital. It's the capital, and that Balacanel is like a town that's...
That makes sense.
It's got two roads that run side by side, and there's houses down the length of the road.
So that would be Douglas then, yeah.
So that means that all your maths boys, how sure are you that would be Douglas?
Well, if I look, the camera is going right over top of that star, which is the capital city, right? So that's right there. Right? The camera is right over top of that, whatever that is. I assume that the star means that's the capital city, and that's the capital city.
Yeah, well, now Balacanel is, you'd have to turn the field of view more around to the right, because it's in that cove. In fact, it's to the right of that cove. Can you see that cove at the bottom there? Now, middle of the picture, right on that. Yeah, that cove that you're in there. That right cove here is where Balacanel is, and it's on the right-hand side of that cove. So that's where the cove is. So if the argument is that we got it wrong with Douglas and it was actually Balacanel,
be in here somewhere then, yeah.
Which would be the dots that are in the background there, I would say.
Yeah, it probably goes up a hill, right?
And this, ladies and gentlemen, is why you don't use maths to prove evidence. You use evidence to prove evidence, because maths can be wrong, which is why I said if Nathan had 2 ice creams and I had 2 ice creams, the ballers believe that there's 4 ice creams. But as flat earthers look round at each other and say, we haven't got any ice creams. That's why you don't prove anything with maths. You have to use the evidence. So if you want to believe that there's 4 ice creams because someone says if at the beginning, fine, believe we live on a ball. But me and Nathan will look at each other and say, but we haven't got any ice creams. In exactly the same way that we say, but you haven't got any radius to be calculating standard refraction for. Why would you be calculating for standard refraction using the radius of something that you can't prove exists and we can prove doesn't? Why is that?
Yeah, if there is a wall in the way, then it must be a hologram below this line. Well, we propose there is no wall in the way. We just see it. Any last comments? Any other bits you want to add just to make it that much more concise.
Yeah.
I think you've been pretty concise so far. Excellent presentation, Chris.
Rumpus sucks. GeoStrieber sucks. Maths doesn't prove anything. Miles Davis sucks. We were right. We are seeing Isle of Man. Maybe not on the south side, but definitely on the north side. Ladies and gentlemen, thank you and good night.
You, Chris, anything to add?
Thank you very much. Yeah, it was kind of an interesting little challenge on the fly. So I'm glad to be of help. So please help you guys out. Cheers.
Brilliant stuff. Well, with that, I will say a huge thank you to the live audience for tuning in. Be sure to like, comment, share and subscribe. Massive thank you to Sleeping Warrior and Chris Monk. I've been Nathan Oakley and I'll see you all in the next video.